I'll be doing number 33. So it says that when the spring is compressed in the gun, like when you're pressing it down, the distance is 0.120 meters, and the gun is fired vertically, so it's just pointing upwards, and it can launch, and then the bullet is 20.0 grams to a maximum height of, it goes all the way over here, like 20.0 meters above the starting point. And then it wants to find the spring constant. So the first thing you need to do is set up the equation UG, because there's limited information, so it's better if, so this is the easiest way to solve for this, and this is basically solving for the total amount of energy, because at the highest point at 20.0 meters, there's a, like, I'd like to think of it as when it reaches the maximum height, there's like the final velocity would be 0, so that's like, I don't, like the final point. So then UG equals mgh. So then you find your total amount of energy in this scenario, and then after you need to, it wants the k because we haven't solved for k yet. So then you do US equals 1/2 kx squared, and then you can find k, which is 544.44 newtons per meter. And then now it wants you to solve for b, which is the speed of the projectile as it moves through the equilibrium position. So then it wants to find, as soon as the spring releases, what is the ball's speed. So as soon as it goes like this, and then you want to find the speed of the ball. So you know the change in x, which is 0.120 meters, which is the compression, and then you know the initial velocity is 0 because the spring is coiled at that before, and then you want to find the final velocity. So then first you use the equation W equals max, or W equals fx, to find acceleration, and then you find that acceleration is 1,633.33 meters per second squared. And then you can use the kinematic equation Vf squared equals Vi squared, but Vi, which is 0. So then you can skip that part. So Vf squared equals 2ax. And then you get the final velocity, which is around 19.79 meters per second.